Good morning, everybody, and welcome. So I think we can start with day number 2 about the training course for the GMA broadcast system. As you can see from the slides, today we are going through some details relative to the circuit and equipment. Um, The first one is a GPS sync and sync generator. So first thing is why we need to have a sync generator. In video synchronization, it's a fundamental items because video the video is not continuous along the time. It's not a sine wave. You have one frame, then another frame, then another one, and so on. So let's imagine you have 3 cameras. Each one takes one frame every, 25 frames every second. But the 3 cameras may have, should have a synchronization to have the starting of the frame and the end of the frame exactly in the same moment. We will see that better later, but it's just to tell you that the synchronization is a fundamental items for the video and also for audio, digital audio in some specifically, not analog one, but for video and digital audio, it's fundamentals. To get synchronization, uh, there are many ways to have synchronization system in a broadcast environment. Um, in this year, the best solution, the best technical solution is to use a GPS reference signal. GPS is ubiquitous around the world because it's a standard. And of course, we don't need the global positioning system like global positioning system. We don't care about our position, but we care about the sync signal inside the GPS signal. So as you can see, we have the slide is divided in 2 parts. The upper part is the roof in Bâtiment M, where we have 2 Furuno antennas. Furuno is a Japanese brand which build this antenna. The antenna itself is not so big. I think it's a 25 centimeter length, no more. Sorry. The antenna is mounted on the roof, and then we have a small device from another company, which is Tor company, which is able to convert the RF signal from the antenna to a fiber optics. And the signal goes down and goes into a fiber optic coupler, which divide the signal on 2 fiber. From 1 fiber, we have 2 output in this way. One of the key point, we will see later better, but just I tell you, it's the antenna is not a simple antenna, but it contains some electronic, and it contains an amplifier, and the amplifier is powered by a power supply, and of course, if one GPS system is maybe in the future may have a problem, one of the first thing that you have to do is check that power supply, because fiber itself, it's very strong, it's very resilient, uh, and also the Tor system are very resilient. The weak point in this case can be the power supply. Please check it if you have, first of all, if you have a trouble. So in the fiber arrives in EQR1. Uh, Really, this slide is not correct formally, but it is correct from a conceptual point of view, because we have just one fiber from bâtiment M to the EQR1, and on this fiber we have a signal for EQR1 and EQR2, because from EQR1 the signal is routed through the fiber in EQR2. So from a formal point of view is not true what is written into the slide, but from technical point of view is correct, because we have one antenna for EQR1 and one antenna for EQR2. The antenna are mounted on the roof, and the distance between the antenna, I think it's 3 or 4 meters, no more. That means both antenna receive the same satellite, and of course the reference signal which comes out from the GPS system is identical for EQR1 and EQR2. This is the reason why, even if they are not connected physically, but they are connected through the GPS, and then EQR1 and EQR2, or if you prefer, the entire system for the pre-roll, garden, esplanade, minaret, uh, Obi-Wan, is synchronized with the polyvalent room and associated areas, of course, which means backstage, auditorium, archive, and edit suite. This is in slide number 5. What you can see is it is exactly what we have seen in the slide before, but in the previous slide, but now we have a schematics which tells us what's going on. Um, you can find also this picture at on the technical manual page 65. Again, please take care about the power supply, which is this one, which supply the plus 5 volts to the front antenna. This is the first thing that you have to check. So the next slide, it's this one. Please, Marco, can you exchange on the other one? Yes. So here we have the real schematics which describe the situation in bâtiment M. If I enlarge the picture here, okay, we have the front antenna, which through coax cable goes into the control room in bâtiment M, and then we have a converter which takes the RF and transform this signal into fiber optics signal, which goes to a Tor device, and this Tor device from the same signal give us two identical outputs. So if we move on there is a patch panel, fiber patch panel in Bâtiment M control room, where we have in position, it's better if I enlarge, okay, 11U and 12, just a second because, okay, 11, okay, this one, the first and the third, 11U and 12U, we have signal from one antenna, and in position 11D and 12D, the signal for the other antenna. Signal goes to the AQR1 through this 24 fiber cable. As you can see, the signal still separate along the path from Bâtiment M to the AQR1. Well, please, Marco, can you change back? Okay. Synchronization, the signal arrives inside the AQR1, and let's talk just for the AQR1 because AQR2 is exactly identical, that we can describe just AQR1. And what kind of a signal we need to synchronize the system? We need video reference signal, which is called black burst. And this is the only analog video signal that we have in GMA. In GMA, all the signal are video signal are numeric, digital, and we have just one type of video signal analog, which is the black burst. Black burst is called because it's a normal PAL, in our case, of course, because Algeria is a PAL country. It's a normal video PAL signal, simply without picture. So it's black. This is the reason why it is, oh, sorry. This is the reason why it's called black, because no picture on it, and we don't need it. Marco, please, can you exchange on the whiteboard? Just to give you an idea, the black burst is like a signal. If you look at the black burst on oscilloscope, what you get is, oh, sorry. Non vedete la lavagna? You cannot see the.
No.
Okay, it's a delay time through internet. Sorry. Okay. Black burst is a signal like this one. Okay. Now we have a sync. We have a burst. Then we have video. Then we have a sync again. We have a burst. And we have video. In PAL, the distance between this point and that point, the distance in time is 64 microseconds. Exactly 64 microseconds. Time duration of this sync is 4.2 microseconds. Uh, this number are important because this signal is called black burst. It's composed by a sync, sorry. This one is color burst, and if the video is present, it should be in this position, but of course, it's black. There is no video. Every device who accepts the black burst will use this sync to synchronize itself on the video. Until some years ago, device was using also the burst. Burst contains the subcarrier, the color subcarrier, 4.433 megahertz in PAL. But now the actual device use the black burst, but don't care about the subcarrier, but just they need sync. Um, just a note. In with the modern TV system means from HD to 3G, 6G, 12G, and so on. Another type of synchronization signal has been developed, which is drawn like this one, and is called three-level sync. Normally, all the modern devices have a BNC on the rear, which accept a reference signal, and the reference signal, of course, can be black burst or three-level sync. And which one is can be decided through the software. You at the setup moment, the first setup of the machine, you have to tell the machine you have to use sync, black burst signal, or three-level sync. The main problem with the three-level sync is that the signal is related to the uh, standard used, 12G, HD, or whatever. But this means you have to generate different three-level sync for different standard. Black burst is a common signal for all the standard. Even if it's still analog, it's a common signal for all the standard. That means in X, maybe the XDS PD1000, which is a video recorder HD, or XVS 7000, which is the video mixer, which works at 12G, we supply blackburst and blackburst, and the two devices are synchronized. So the three-level sync is not used in GMI broadcast. Is used just the blackburst distribution, and called also reference signal. Any question? No?
Yes, Maurizio, please.
Yeah.
Could you go to slide number 4?
Slide number 4, yes. Okay.
Not yet. Not yet, Maurizio.
Hello? Hello?
Yes.
Yeah. Marco, please, can you switch to slide number 4?
Thank you. Here, Maurizio, please.
Okay.
You told us that GPS number 1 it's for EQR1
Yes.
and GPS number 2 for EQR2.
Yeah.
But like this, we lose the redundancy concept. You told me yesterday
Sorry,
that
I cannot hear you very well.
for the GPS,
Yeah.
you told us that GPS 1 for EQR1.
Yeah.
So the fiber coupler, it's for the same destination.
Yes.
But like this, we have no redundancy between GPS.
Like this, you have no redundancy about the GPS. That's correct. You cannot have, because the system is not provided by automatic changeover. But there is some workaround that I show you later on how to keep the system synchronized in any way.
Maurizio, please, if you
because
go to the next drawing.
Yeah.
Next one.
Next one. Yeah. No, you mean the drawing?
Yes, exactly.
Just a second, please. Should be this one. Yes. Okay. Marco, can you switch to the drawing?
Here we follow the coupler. We found that they will go to 2 different destinations. One to building A, one to building D.
Correct.
The labels here, but it's different in the first one. Which one is right?
Sorry, just a second, please. Marco, io il microfono lo sento bassissimo, non riesco a capire. Sì. Just a second, please.
Okay. You hear me, Maurizio?
Yes.
Here
yes.
in this drawing, it follows the coupling.
Yeah.
From the coupler, we have 2 different destinations. So GPS 1 go to EQR1, EQR2. GPS 2 go to EQR1, EQR2.
Yes.
But it's different in the first one. So like this, we have redundancy. In the first one, we haven't.
No. I'm sorry, but this is not true. We will, maybe Marco or Omar will show you later. Those 2 fiber, you can see my pen.
Yes.
those two fibers, this one and that one, goes to the EQR1, and once they arrive in EQR1, they goes straight to EQR2 without staying in EQR1.
Yes, I understood that.
No, Maurizio,
The labeling here.
Yeah,
what Walid want the first slide in the presentation, and
yeah.
it's just a general idea. It's not the real installation, like we discussed before. It's just a
Yeah.
concept, yeah, point of view.
So, physically, the two GPS are separated from
The drawing, this drawing is the real situation. This one is just.
yeah, but Omar,
Yes.
what I am saying is the, the signal is passing through the EQR1 and goes straight to EQR2.
Yes.
It's like a unique fiber which goes from one side to another. Just for technical reason pass through the EQR1, but in EQR1 the fiber for the GPS2 has nothing to do, it's just a pass through.
I know, for that it's clear. For the coupler, one coupler,
Yeah.
have one destination or two destination. It will go only for EQR1 or for EQR1, EQR2. Because normally, yes.
Sorry, but I do not understand exactly what you mean.
Wait a moment.
It's okay now, Maurizio. Thank you. Omar
it is
explained
clear.
to me. We have redundancy.
We have a different type of redundancy. Later on, between some slide, you should see and how to have redundancy about that. But Omar,
Yes.
please, in the afternoon, maybe you can show him the system, the entire system about the GPS.
Sure.
Okay.
Okay.
Okay. Okay. Thank you. Thank you very much.
You're welcome.
So, we were talking about the black burst. Where is it? We were talking about the black burst here, and we use this signal to synchronize all the devices, video device, which are installed in GMA broadcast system. We have also word clock signal, which is used for synchronization of the audio, digital audio. If you remember, yesterday we saw a digital audio signal like, I can go back to show you just a second, which is the last. Okay. Please, Marco, can you exchange on the... Okay, you can see the picture.
Yes.
No, dove c'è digital audio, sì, la lavagna. Okay, you can see the picture about digital audio.
Yes.
Okay, so yesterday we saw that every subframe is composed by 32-bit. So 32-bit are there are some synchronization bit, some auxiliary bit, the digital audio sample data, and some control bit. But this kind of signal does not contain any identifier. So there is no way to know if this one is subframe 1, subframe 2, subframe 3, or whatever. It's just a subframe which has a content of digital audio sample data. What does it mean? It means that if we use, sorry, I want to delete everything. No, it's better if I do, no, I want to delete. Come on. Okay. So let's imagine I have a microphone. Oh, sorry. I have a microphone. This is a microphone. I have the amplifier, and I have an audio to digital converter. So this output is an audio. It's an audio sample. Uh, Contains some audio sample in digital. So there are many packets of 32-bit which comes out from this one. Then I have those stream goes into the audio mixer. Then I have another microphone, just to have an example, or another source audio, it doesn't matter which is. Same configuration, converter, and another stream which comes out and goes into the mixer. So if just one arrives, mixer has no problem, takes this audio at the input and give us the audio on the speaker at the output. But if a second one arrives and I want to mix the two signal, maybe I can have some problem, because it may be possible that one packet from the first one arrives, but the packet from the second one arrives here. If I want to mix it in digital world, those two packets are not synchronized, are not in timing. But if I give you a word clock, word clock, to the converter, at the input of the audio mixer, the two packets are exactly in the same times and are synchronized, and then I can mix it. This is the reason why in AES we have to use the word clock signal to synchronize source and destination. It's okay? It's clear? Um, okay. Then from the GPS, we get also some time reference. One is time code. Time code is a numeric code. It's composed by 80 bit and is in the form hour, minute, second, and frame. And it is typically used for recorder, video recorder. It doesn't matter if it is a video recorder on a tape or video recorder on a disc or video recorder on a static RAM or whatever. But it's fundamental to have this one. Let's make an example that can help you. Let's suppose that we have a recorder which receive a video and another recorder which received the same video at the same time. We supply to the recorder a time code from external, and this time code, those two are identical. So that means if it's noon, at this moment arrives 12:00:00, and then start the frame, maybe frame 2. So the recorder will record the same picture. Remember, the picture are synchronized through the black burst. So that means the time which arrived the picture inside the recorder are exactly the same. And the recorder, together with the picture, will record under each frame the time code. So he said this one is 12, frame 12, 00:00:2. This one is 12:00:00:3, and so on. When arrives to 24 in this case because we count 0, the counting start back to 12:00:01:00, because after 25 frame we have 1 second, and so on. That means each frame on each recorder has an time identifier, which is represented by the time code. Why this is important? Because let's imagine that you want to use those two recordings to be edited and give an output like a film. So you get one picture from here and one picture from there. Of course, the two pictures are identical, then it's easy. But what happens if this one is camera 1 and this is camera 2? Those two pictures are not identical, are synchronized, but not identical. So, in the same time that something happened on camera 1, something else different happened in camera 2. And the only way that you have to compare the two recordings is using timecode. Because if in camera 1 you have an event at frame 00002, and in recorder 2 you have another event at the same time, then you have a relationship between the two recordings using a time code. And if you edit a film or a documentary or whatever you want, it's important to have um, an absolute reference time. This is the reason why in GMA, time code is locked to the GPS. So this is absolute reference time from GPS is very precise and is distributed over all the recorder system, 12G and HD. Maybe this afternoon someone show you that the time on the recorder is the same in everywhere, in EQR1 or in EQR2. It's exactly the same. We have other two type of uh, uh, time control. One is the traditional NTP, which is Network Time Protocol, can be used to synchronize the computer. Can be used if you go into the control room. There are two clocks on the wall which count from. Uh, they show you the right time. These clock are synchronized through the NTP, and then we have um, another time of protocol which is called PTP. PTP means precision time protocol. Why we have to use two different type of uh, protocol like NTP and PTP? Because the inherent precision of the NTP can vary from 1 millisecond to 5, 7 millisecond, which is a good precision, but not so good to synchronize video equipment. Precision Time Protocol, PTP, has a precision of 2 nanoseconds. This is 10 minus 9, and this is 10 minus 3. So it's very, very precise, this one. And in the system, in GMA system, is used by Riddle device. All the other system use time code and network time protocol. But Riddle device require PTP. More in general, PTP allow it's not such a new idea because the original idea of the PTP was was developed for the network protocol. And if you need more information or you want to see more information, you can give me. Marco, can you switch to slides? Okay. Why is not working? Okay. You can check on internet about the. I show you the front of the document. Should be this one. Where is it? Okay, this is. You have to search for this document, which is standard 1588. This is the origin of the PTP. First evolved for Ethernet network. Large Ethernet network means Ethernet over the world, which connect different region of the world. And on this standard, the SMPT has evolved the PTP for video. Essentially is the same with some extension for video. Okay, we get back. One of the main important thing is that from a GPS signal, we get blackburst, word clock, time code, NTP, and PTP, and all of these are synchronized between them. This allows us to insert AS signal into the video. For the audio analog, there are no big problem. You can use audio analog everywhere. But with the digital video and digital audio, we have to think in terms of a packet of data, not a continuous data. That means you have to synchronize the packet. Otherwise, you cannot do anything with the audio and digital video together. At the very first time of the digital video, more than 30 years ago, some Sony machine have a special circuitry to synchronize the digital audio applied to the video. Was the first time that this phenomena was in place, because if you go in at that time, the digital machine has digital video and analog audio input and was perfect. But when you want to apply digital audio, often a message was appearing on the display, which was saying not audio applied, not synchronous. There was a special circuitry inside which make a time correction on the audio and make this audio synchronous. Now everything like this one disappeared, of course, because it's automatically, but with the audio digital AS, we still have the necessity to use word clock to synchronize audio between two different audio. Audio referenced to, if we want to embed, if I want to embed some audio on a digital video. So, any question?
Yes, Maurizio, please. About
Yeah.
PTP, I have a question. Why we use
Yeah.
PTP only in reader device? It's a choice or obligation?
From Riddle point of view, it's an obligation.
Why?
Riddle require PTP.
Okay, thank you.
The other machine not. But the Riddle require PTP. Yes.
Thank you.
It's a specification from Riddle itself. Yeah. In the next slide, well, so if you
Maurizio, sorry, we have another
Marco,
question.
please, can you change on the slide?
Mauricio,
Yeah,
we have another question.
yeah.
Hello?
Sorry. Yeah, tell me.
Can you hear me?
Yeah,
So, can you go back to the last slide?
this one?
Yeah. As we can see, PTP minimal time precision is 2 nanoseconds.
Sorry, I can't hear you. PTP?
Minimal time precision is 2 nanosecond.
Yeah.
If we have a network that have latency bigger than that, which is the case, how do we synchronize equipment with PTP?
You're talking about Ethernet network.
Yeah.
Oh, this is very complicated. I mean, latency, I don't know exactly how it works on the Ethernet network. What I can do, how it works on video. Let's imagine, Marco, can you exchange on the whiteboard? Okay, thanks. Now, let's suppose, sorry. Yeah. This is our planet. Here we have New York. And here we have London. Through the PTP, it is possible. We have satellites, GPS satellites, and GPS satellites send a signal over London, but all the GPS satellites are synchronized between them. So there are 1 or 2 GPS satellites which send a signal over New York. Then through a terrestrial or satellites or whatever network, there is a communication between the 2 stations. And if you go into the document that I show you, it's explained very well. And this one, maybe it's a master. And this one asks to the master, please tell me the time in your location. Master send back the data and says, okay, I am at this point. There is an exchange of data between, and this one is able to calculate the delay which exists between this point and that point. This delay through PTP is within 2 nanoseconds. So the error of the delay is within 2 nanoseconds. I'm not familiar with the Ethernet protocol about that problem, but 2 nanoseconds, this is one of the requirements for video, because in the old analog system, 2 nanoseconds was 1 color degree in PAL system. This is the reason why in video we use that one. If you want more information about the PTP used on the network, you have to check with the document that I show you before. Is explained very well.
Okay,
Is it
thank you.
clear?
Yeah, okay, thank you.
Can I add one thing? In GMA we have 2 antenna, and we synchronize EQR1 and EQR2. But with the PTP, EQR1 can be here, and EQR2 can be in London. And they still synchronized, even with this distance, because they are synchronized to the same satellite GPS, and all the satellite GPS are synchronized one to each other. And the delay between the satellites is fixed. Is it clear? Hello?
Yeah, for the case of satellites, it's clear. We calculate delay and we extract delay. That's it.
Sorry, can you repeat?
I said it was clear for the satellite. My question was about Ethernet network.
I'm sorry, but I'm not so familiar with the Ethernet network. Because the original document has been developed for Ethernet, and if you take a note about the document that I show you, you have to read this document.
Okay, okay. In GMA, we don't have connection between readable device.
In GMA, there is a connection between the readable device, yes.
Yeah, for the synchronization between the readable the device, how it is done.
Yeah, but it's readable device has a protocol embedded between the readable device, which transfer and use also the PTP. In detail, internally, I have to be honest, I don't know what happened, but the requirement for this application is please use PTP. This is the reason why we have installed the option, because PTP is an option. We have installed the option into the sync generator.
Okay.
Hello?
Yeah, that was clear. So we have
Okay.
different source.
Can I go on?
Yeah, you can go on. Thank you.
Marco, please, can you exchange on the other slide? Okay. The GPS signal from the receiver arrives to the SPG, signal pulse generator. We have two signal pulse generator for EQR1 and two signal pulse generator for EQR2. The signal pulse generator are connected to a changeover. What does it mean? It means that every signal from a single generator has a connection to the changeover, and the changeover is a device which check in real time all the signal. So we have black burst from this generator to the changeover, time code from this generator to changeover, word clock this generator to changeover, NTP and PTP. If one of those two will fail, means if a GPS RF is not arriving or the device itself will fail, the changeover switch automatically on the other one. Then the output of changeover, we have always signal at the output. This is the reason why we have a changeover inside, because we need a continuity of the synchronization signal for the entire system. In EQR1, same thing happened in EQR2. Sorry. Okay, now we can see. Please, Marco, can you switch to a slide? Okay, I don't need this one. And I need that one. Okay, this is the schematics of the EQR1, but it is absolutely similar, identical to the EQR2. So, these are the two fiber which comes from the bâtiment M. If you remember, was in position 11U and 11D for the QR1. Sorry. Okay. The two fiber will arrive into the third device, which converts from fiber to coax again. If you go in a QR1 and you look at the top of rack number 1, you will see those two devices. Then, with the coax cable, the GPS signal is supplied to the SPG, to the generator. And of course, on this side, the same thing happened. So the two generators are not connected together, but are connected together through the GPS. And then they receive the same signal here and the same signal here, and that means the output of the generator are synchronized. Every generator has 6 black burst output, 1 digital audio output, silence output, and word clock. AS output and silence out is not used, is just connected but not used. We use word clock and we use time code. PTP is connected here. It is an option inside the generator, and it is connected on the LAN because PTP is a protocol on the LAN. If you look at here, goes to reader device. We have a LAN here, and on this LAN we have also the NTP which goes to the general system. Then the output of the changeover, we have changed, this is the changeover which receives signal from SPG number 1 and signals from SPG number 2. The changeover check every signal in every moment continuously and make a choice if use this input or that input to give us a continuity input, continuity output in this position. We have these lines, light blue lines, are the reference, black burst reference. There are 3 lines which goes directly to the video switcher, video router, and frame. We will see later what is it. It's an Everts frame which contains a lot of electronics. The other output goes to the distribution amplifier. These are analog distribution amplifier, and the distribution amplifier is a device which receives an input and give us 6 output at the same time, and these output are distributed to the system, all the device. This is a video recorder, this is a processor, this is H video recorder, this is a waveform, and so on, including, of course, the reference for the camera 1 to camera 18. This is the reason why we have only 6 output, but we have to use a video distribution amplifier to distribute the analog reference signal everywhere. We have also a word clock distribution amplifier because we have some device which require those radio microphone are not installed because are optional, but the radio microphone needs the word clock, and this is why we have put a cable from the distribution amplifier to the position where the radio microphone can be installed. And we have also word clock to the audio mixer. We have 2 audio mixer, and the audio mixer will receive the word clock. We have also a time code distribution system, which from the time code input give us up to 8 output, and we use the first 5 for the 3 recorder, video recorder, and for 2 12G video recorder from Sony. I mean, all of these are from Sony, but The first three are HD, and the last two are up to 12G. If you remember, I told you before that distribution of the time code on the recorder is fundamental to have a reference point between different recording source, one camera, two camera, and so on. Let's Marco, can you switch back please to okay, thanks. Oh yeah, this is a big point. Uh, I think we may have a break now because I don't want to start with the riddle system now because it's so important and so long. I know. What do you think?
Okay. Little post coffee ونوليو.
Hello?
Okay, Maurizio.
I have no answer from. Okay.
Okay.
Okay. We have a 15-minute break, please.
Okay. Ciao Maurizio. We can continue.
Okay.
Okay.
So, we can continue after the small break. Riddle. In GMA, we have two riddle system. The two riddle system are interconnected, but they perform different tasks. One is the intercom system, which allow us to have some station like this one. This is the front and this is the rear of the same station. And in this position, we have a microphone, or we cannot have. It depends, but generally speaking, we have a microphone. And then through the smart panel, various area of the GMA, they can talk together. The area are grouped, can be single area, single user, or multiple user, depends on the program which has been stored into the reader system. All the panel are connected to the Riddle Artist Intercom Matrix, which is located in EQR1. And this is one of the items that I told you the first day when I was talking about that the two systems in EQR1 and EQR2 are identical, but some electronics are only in EQR1, and this electronics will be used overall by EQR1, EQR2, Minaret, and so on. This is one of the device which is installed in EQR1 and will be used by the entire system. All the panels are connected on the Riddle virtual LAN through Ethernet, of course, and there are some panel which are not really not panel, but it's called the Bolero antenna, which is not a simple antenna, but it contains a lot of electronic and allow the intercom to be extended over belt pack. Belt pack means intercom through RF. We have Bolero system in pre-roll, and also in auditorium. Yeah, on the back panel there are various connection, and one of the most important is analog 4-wire input-output connector that we will see later. Is used for audio, and we will see later that one. So then we have another kind of equipment, always Riddle, but in completely different type of equipment, which is dedicated to the video. This is Riddle MediaNet Micro N, and then we have Micro N UHD, and then we have MN Compact Pro. First of all, I want to show you the original Riddle MediaNet network, just to explain exactly what does it mean. Uh, no, this is not the good one. This is the good one. Yeah, no. Please, Marco, can you switch to... Okay. So this drawing is the original drawings from Riddle, where we have different area, control room, minaret, auditorium, lobby van, and the bâtiment M, and 2 fly cages. Okay. Into the control room A, which means EQR1, we have some devices from Riddle, and in particular we have this mesh. Maybe we can talk about mesh later on, but for now it's important to understand these things. From the EQR1 there are 12 link which goes to the minaret. 12 link means 24 fiber. There is one link, there is one cable with 12 link, 24 fibers to the auditorium. Then we have to the obivan 12 link, 24 fibers, and we have 5 link with 10 fibers to the bâtiment M. If you look, the basic configuration between the various area is always the same. We have Micro N UHD and Compact Pro in each area. Micro N UHD Compact Pro, Micro N UHD Compact Pro, Micro N UHD Compact Pro. And in Bâtiment M we have just Micro N. But Riddle MediaNet is used for? This is the question. Well, it's a generic transport network, proprietary network from Riddle, on which can travel some video, audio, and other kind of signal. We have, maybe in this case, with this number of lines, 24 single fiber, we may have 24 in or 24 out 3G, or 8 in, 8 out 12G SDI. So If I connect on the micro N UHD a 12G video, I can send this video through the MediorNet network directly to the minaret or to the auditorium, or at the same time to the minaret and auditorium and OBVAN. This is the basic function because we have interfaces which are Compact Pro and Micro N UHD. Micro N is dedicated for the video, 12G and HD. Compact Pro has also some audio, timecode, digital audio, and video interface, but up to 3G, not 12G. It's important to understand the concept of mesh. Uh, let's say I can do a drawing just to have a clear view of the mesh. Okay. Mesh. Let's imagine you have, oh, sorry. Let's imagine you have 4 devices connected with a network. This is A, B, C, and D. Okay. Those devices have a capability to, if I want to send data from D to B, A can be a pass-through, then the data can pass through and goes to B. Of course, I can send D to A also, or D to C also. But if one link fail, I have another possibility because this one is broken, and then I can use D, C, and goes to B back. This is a very simple mesh. In other words, we have a different path to reach the same destination or to connect a source with a destination. Riddle mesh has expanded this concept, and it's like this one. We have a connection, basic connection. Then we have other connection like this one, and then we have other connection like this one. So the resiliency of the system is increased because if one link will fail, we can find always another path to go through to reach from D to B, for instance. Of course, this is just a concept, but Riddle makes that in reality. They build that. And now we will see how this happened. Now we can see the Riddle mesh, original Riddle mesh, okay? Please, Marco, can you exchange on the other one? No, sorry, get back on the other, yeah. This is the riddle mesh. So the green area is EQR1, and it's a fiber patch panel in EQR1. Let's consider just one. We have this patch, which is connected with in EQR1, which is connected with two fiber 24 core to the minaret. So what does it mean? This is a terminal from fiber point of view in EQR1 of the minaret. Same thing we have here with this patch in EQR1, which is the terminal, the fiber terminal for the bâtiment M. This one is the terminal, fiber terminal in EQR1 for the OB-van. And then we have also a fiber terminal here for the polyvalent. So 1, 2, 3, 4, and 5 panels. This is the panel which it's a terminal for EQR1 itself, because also in EQR1 we have a Compact Pro and Micro N UHD. Those panels are one very close one to the other, so we can connect with the patch cord from one position to another as we wish. We can build in this way what the riddle call the mesh. Sorry, mesh has been developed by Riddle, keeping in account the data rate and the necessity of data throughput between the various devices. There is a particularity that we have to remember well. Marco, can you please switch back on the slide? Okay. So this is a Micro N UHD, which is present everywhere except the bâtiment M. And we have 4 QSFP connected here, inserted here. But 3 QSFP are used for the mesh, and 1 QSFP is used to connect directly the Compact Pro. Please, Marco, can you get back on the other drawing? If you check the drawing, this is Micro N UHD. We have QSFP1, QSFP2, QSFP3 connected to the patch, the fiber patch in this position. But the QSFP4 is straight connected to the Compact Pro. This is a standard configuration for GMA. Every Micro N UHD has 4 QSFP. 3 QSFP are used for the mesh, and the 4th one is used for the Compact Pro. If you remember from yesterday, we have already said that each QSFP can handle four links. Means 8 fiber. So we have in this case 8 fiber, 8 fiber, 8 fiber, a total of 24. And we have a fiber patch in EQR1 connected with two 24 cable, 24 core fiber to the fiber patch in minaret. The first 12 are, if you look at here, we have the first 8 plus from QSFP2 4 fiber. 12 connection goes on this fiber and 12 connection goes on that fiber. Why we don't use just one fiber for all the 24? To have redundancy. Because if this fiber will fail, of course, all these connection will be broken, but the other 12 connections are still in place. And then the mesh still working. Of course, at reduced bandwidth, because if some connection are lost, no problem. But it's better to have the connection with lower quality instead to have a black picture. And this is the reason why this kind of arrangement has been used everywhere. As you can see, we have also here from Obivan 12 on one fiber and 12 connection on the other fiber. There is one exception, which is for the bâtiment M, in which right now the MediaNet fiber are not used, are connected, are powered. Device in bâtiment M is powered, but these fiber are not used right now. Maybe in the future could be used. Difference between bâtiment M and the other mesh device is the presence of micro N simple and not micro N UHD device. So this micro N can handle just signal up to 3G, but not 12G. This has been done because in the future, maybe someone wants to install a satellite link or want to install microwave bridge from Bâtiment M to the national television or whatever, and then the signal, of course, cannot be 12G, but the signal it's HD or 3G can be inserted. Well, I mean, can be this is the output which can go there, go on the microwave link, and we can also have from microwave link a video which comes in and through the MediaNet arrives inside into the GMA system and can be distributed in EQR1 or in EQR2 or whatever we need. Any question? No question?
It's okay.
Okay. So riddle Micro N UHD on the rear has the QSFP connection to the mesh, and it has also video in, video out. The micro BNC with the white background are 12G. The micro BNC with the black background are HD or 3G. Connected on the system and on the patch panel, we have these four, and these 8 as input. And as output, we have these micro BNC connected. The central micro BNC are not used in GMA. They can be bidirectional, HD or 3G. That means through the software you can tell to the machine this one can be an input or an output in any combination you want. But we don't need it. What we need mainly is to have the green one, where we have 4 input 12G and on the other side 4 output 12G. These other, through the software, have been converted to HD in and HD out. So that means through the micro N we can send video with audio embedded everywhere on the Riddle MediorNet, and at the same time we can receive video with audio embedded from MediorNet on the micro N UHD. We will see later how to do that, but it's not so difficult. Micro N UHD, or better, Reader system has also the capability to transport not only video but also audio, MADI signal, which is multiple audio. We don't use it, is on fiber in this 2 point, but we have not, and Ethernet. So that means you can insert an Ethernet channel here, and through the software you can tell to the MediorNet to send this channel to another destination to extend the Ethernet. It is not a switch. I mean, Ethernet connection are always point to point. If this one is micro NUHD in Minaret, you can connect a computer here, and in micro NUHD in Equran, you can connect a switch. Then you have extended the output of the switch to the computer in Minaret, but you cannot move this Ethernet at the same time on another micro N. You can switch to another, but you lose the connection here. It's always point to point. It's very useful for service, for instance. So, another interface that we have seen before is the micro N, the MN Compact Pro. This one. The Compact Pro receive the 8 fiber on the rear, and it has some connection interface like video in, video out, from HD to 3G, digital audio, Ethernet port, as we have already seen for the micro N. And there is a RockNet line in out. RockNet is a proprietary Riddle system to transport audio from one location to another through the MediaNet. We will get back on this later on. Of course, if I insert maybe on channel 3 an HD video, I can tell to the system, please send this video to the output number 4 on the micro N UHD in Minaret, for instance. In other words, MediaNet can be used to transport video from one side to another, or audio, or video and audio, or whatever. But it is itself a video router, because I can instruct the machine to send the video to any location that I want. It's really a video router. In Bâtiment M, we have micro N, not micro N UHD, micro N. He is connected with 5 links. If you remember from the drawing, we saw we have 10 fiber, means 5 links. And the system has video in and video out. Video in and video out can be used to connect anything we want into the micro N, but up to 3G. Micro N cannot handle 12G. And now we can see the Riddle mesh table, for instance. Okay. Okay. So this is the Riddle mesh table. It's not a complete one, it's just a part of it, but it's as you can see, we have micro NUHD, pre-roll EQR1. The area is pre-roll, but the room is EQR1. The node ID is the number ID of the micro NUHD in EQR1, which is 1 in this case. Link 1 is connected to the micro N link 1 in the minaret. So if we go back to the drawing that we had before, this one, link 1, which is QSFP1, this is the micro N in EQR1, micro N UHD in EQR1, okay? QSFP1, link 1 is this one, is connected with link 1, oh sorry, is connected to the link 1 in Bâtiment B. So in EQR1 we have a patch cord which connect this position to that position. And if we look at the next one, okay, and then we have micro NUHD, always in a QR1. Link 2 is connected to micro NUHD auditorium, link 1. So in this case, a lot of connection goes through other connection, and then we realize the mesh. There is a drawing about that mesh which allow you to see how the system is connected. All these connections are fixed, so that means there is no reason to change these connections. If everything is still working, this connection on the fiber patch panel should be considered fixed. There is no reason to change it. If there are troubles, if there are problems, yes, you can change and try. But if there is no good reason, those connections should be fixed in place. Any question?
Yes, Maurizio, please. I want just to know the difference between the ports SDE 3G in the Compact Pro and in Micro and UHD. What's the difference between them?
Okay, Marco, please, can you exchange? Okay, you mean between these ports and these ports?
Exactly.
No difference. I mean, it's are just video port that can handle HD or 3G signal.
So if we connect here on in the other equipment, it's the same.
Yes, but it's better if I. Marco, please, can you exchange on the whiteboard? Non ho capito.
Walid,
So,
it's the same port. We use the Compact Pro more or less for the audio, for example, because the Micro N UHD or they don't have in and out for the audio. Yes, Mauricio?
yeah, this is one of the reasons. Yes, of course. But let's say, sorry, let's say I have, let's imagine that this is micro N UHD. This is port number 3 HD out. Then here we are in AQR1, for instance. Okay, let's imagine here we are in the minaret. Then in the minaret, I can bring a camera, video camera, the output goes to the compact the input number 2 HD. Through MediaNet, I can say to the system, please take this signal, go to the micro N UHD and go to on the output number 3 in this case, where is a monitor that we can see the camera. If the camera is 12G, instead of connected to the Compact Pro, which cannot handle the 12G, in the minaret we have also a micro N UHD. Then I move this connector from here to the input 1 of 12G. Here I have the output 1 or the output 3, whatever, 12G, and I can connect a monitor 12G to see the camera. Is it clear?
Sorry, but not really. So, if I really understand, we can work only with Micro and UHD without Compact Pro?
Yes.
So, why we have this equipment?
You mean why we have a Micro N UHD and Compact Pro?
We can use only Micro and UHD.
Yes, of course. But Micro N UHD has only video in and video output, has not audio, analog audio, has not digital audio, and if you look at on the rear, Marco, please, can you switch? Yeah, thank you. Okay. We have, in this case, 4 audio analog in, 4 audio analog output, 4 AES channel, which means 8 audio digital channels, 4 Ethernet port, and 4 output sync. This output, you can distribute the black burst to the device in a remote location. So this is another type of interface, more complete, that is not included into the Micro N UHD, which has only the video and the Ethernet output. There are only 2 reference output, but as I told you yesterday, the system GMEA works in HD and works in 12G, works with analog audio and works with digital audio. So what we need is to have a series of interface around which allow us to interconnect a great amount of device without use external converter. This is the reason why we have that.
And the Compact Pro don't have 12G connection.
No.
Yes.
No. No. Compact Pro not. It's only HD or 3G, not 12G.
Okay, thank you, Maurizio.
Okay? Uh, if I can, I want to show you one thing. Just a second, please. Give me a second because uh, I should have a picture with yeah, maybe this one. Yeah, okay. Uh, I show you a picture now. Okay. This is the actual riddle mesh that we have in place in GMA. Um, as you can see, we have, uh, of course, the green connection are the active link, and we have an active link from maybe let's consider from EQR1 to the EQR2 with three active connection video or connection, and the amount of bandwidth used is 16%. The system, it's high resilient because if one link will be broken, a 1 goes to the talk, and then from the talk goes back to the queer 2. It is automatic process. You have not to do nothing on the system, but the system itself automatically will reconfigure itself to get the best connection uh, in the time. We have, and of course, if you look, we have Minaret Micro N UHD connected with the Minaret Compact Pro, but the Minaret Compact, all the Compact Pro are terminal. There are no connection from Compact Pro to other device. The Micro N are device which make a mesh. From the Micro N, not UHD, but M, we have some link for the talk, for the EQR1, one to the EQR2, and one to the minaret. There are some other links, red, which are in place, but right now not used, and are two fly case 1 and fly case 2. Is it clear?
Yes, thank you.
Okay. Perfect. So, Marco, please, can you switch on the other slide? Okay, thank you. So if there are no questions about riddle, I can move forward. Okay?
Est-ce qu'il y a des questions? Okay, Marco, you can continue.
I can go?
Yes.
Okay. About the networking, what we can do is just to have a general idea, because more specific idea will be you can see in place directly, because it's a very extended and complicated. From general point of view, we have physical network and virtual LANs. Physical network are camera network, Dante network, primary and secondary, Shotoku network, primary and secondary, or main and backup as you wish, Sony SharePlay network, and Sony Media network. So these are physical networks, means they means cable, means patch, means switch. Then we have what we call a general LAN, on which we have 4 VLANs: for Everts, for Riedel Intercom, for Sony MVWS LAN, and user management LAN. In the next slides, which is this one, there is a general description. The general LAN, this one, the general LAN, this one, is composed by switch connected together in AQR1 and AQR2, and on this switch we have virtual LAN. Then we have separate switch for Dante, primary and secondary, connected between AQR1 and AQR2. This is why, because Dante network is a network which transport digital audio, and I may have some audio from AQR1 which should go to the AQR2 or vice versa. This is the reason why Dante is connected between AQR1 and AQR2. Shotoku main and Vinten in AQR1 is just for AQR1. We have Shotoku main and backup also in AQR2, but the two Shotoku network does not need to talk one to each other. This is the reason why there are no connection at the level Shotoku level between AQR1 and AQR2. The same is valid for camera. We have a camera LAN switch 1, camera LAN switch 2 in AQR1, and this camera LAN will connect all the devices involved into the video camera, means video camera, BPU, CCU, RCP, and MSAU. But the camera in AQR1 does not need to talk with the camera in AQR2. This is the reason why are not connected. Sony SharePlay is a high-speed network, 10 gigabits, which connect AQR1 to AQR2. And this network is able to move in real time video content from AQR1 to AQR2 and vice versa. It is connected on the PWS 4,500 machines, and you can remote a machine from EQR1 and use a machine in EQR2 like if it will be a local machine, but really this machine is in EQR2. And all this is possible through the high-speed network. Sony Media File is a separate network which allows the um, the transport, we can say that, of the video file between EQR1 and EQR2 and vice versa. The difference is in SharePlay you move video live. You can see the video on the monitor. In media file you move the file. Then when the file has been transported from EQR1 to EQR2 or vice versa, you can play the file. Any question?
Maurizio, please, could you give us a small definition about what is Denti network, what is Shotoku network?
Or Dante, you said Dante network and Shotoku network.
Yes, what is this
Okay,
network? What we have
perfect.
inside?
Yes. Absolutely, yes. Absolutely. So, Marco, please, can you exchange it to the whiteboard? Yes. Okay. 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 Now, Shotoku, oh, sorry, is a PTZ system where PTZ means pan, pan, tilt, and zoom. um, that means we have a video camera mounted on a robotic system which can move the camera up and down or left, right, and move the zoom inside. This device, the robotic, receive data through an Ethernet line. For safety reason, Shotoku use two Ethernet instead of one. One is the main and the other one is the backup. If something happened on the main, you're still able to use the backup to move the camera. Of course, the two Ethernet are also connected to the main computer, to the keyboard, which is not a computer keyboard, but it's a control panel. And the two lines should be on a different switch. completely separate. Okay? This is Shotoku main, and this is Shotoku backup. Is it clear?
Yes, thank you.
Okay. This is for Shotoku. For Dante, the situation is similar, but Dante, let's consider the audio mixer. The audio mixer has two Ethernet. It's Dante primary, PRI, and Dante secondary. Dante primary goes a switch, and Dante secondary goes to another switch. Not connected together, are completely different. But let's say maybe we have here another audio mixer with Dante primary and secondary. Through Dante, if I have a microphone connected here, I can send the microphone through Dante to this mixer, audio mixer. Okay? But we have also, this is AQR2, and this is AQR1. In AQR2, we have the same situation with the two mixer, two switch Dante. This one is connected here and this one here. This one is connected here and that one there. Okay? But also we have a connection between, no, in green is better. Yeah, better. We have a connection from this switch to that one and from this switch to this one. So what does it mean? It means that this microphone can be sent to audio mixer number 1 here in EQR1 or to the audio mixer number 2 in EQR2 through Dante. Why primary and secondary? Because if this one will be broken, for some reason we have a problem, automatically the system switch on the secondary and the audio still arrive in this position. So we have a continuity of the signal. Is clear?
Clear, yes, thanks.
Okay. I think I have another picture to show that I can show you. Just a second, please. Yeah. I can show you that one. This is Dante configuration that we have right now in place, where we have transmitter and receiver, and we have a series of devices connected to Dante network. We have some Yamaha interface like Rio 1608, other Yamaha interface like Rio 3224. We have 4 mixer because there are 2 mixer in Edit 1, in EQR 1, sorry, and 2 mixer in EQR 2. Then through this software, I can connect mix 2, for instance, to mix 1 in EQR 1. And all these devices are interfaced on Dante, and just to click it there, and then I make a connection. And the audio will be transferred from one side to another. It's okay?
Yes.
Yeah, later on, locally, maybe this afternoon, Marco can show you exactly what happened with the Dante controller network. The important thing is to understand that Dante works on primary and secondary, and this is necessary because if one path will fail, the second one immediately take over, and there is audio continuity. Okay?
Maurizio, please, one other question about Shotoko.
Yeah.
The control between the camera PTZ and the keyboard, it's fixed from source to the camera, or we can change between cameras?
Sorry, could you repeat just a second?
The
control
control
between
PTZ between the camera and the keyboard, it's fixed. Each camera have one keyboard, or we can change and switch between them?
No, there is just one keyboard for all the camera.
We have on EQR1 or EQR2 two keyboard, but in the real time you can use one keyboard with one camera. If you select the same camera on the second keyboard, you cannot use it on the same time.
Okay, thank you.
In other words, it works in this way. The keyboard sends a command to the PC which contains a software controller, and the PC send the control to the robotics. On the keyboard, you have a series of buttons that you can select camera 1, camera 2, camera 3. If you press camera 3, you can control the robotics of camera number 3. But the control is not directly from keyboard to the robotics. It's always through the software into the PC.
If you are on the main network, because the second network, the backup one, you can use only the keyboard if you lose the computer on an accident.
Is clear?
Because the keyboard have a small computer inside also for the backup.
It's clear. Any other question?
Clear, thank you.
Okay. So let's go on. Please, Marco, can you switch to the other? Okay. So now we have GMA glue system. Glue is a general terms which describe a series of electronic device like conversion board, amplificator, distribution, um, processor also, which can be video or audio or video and audio together, but it's generally speaking is they are called glue. And why we have that? Because if you remember before, we have seen that the output of the generator has a black burst. But if we have 6 output and we need to distribute the black burst over 20 or 30 machines, we need something in the middle which allow us to distribute the signal. It's a video distributor. Video distributor is a board and in this case this video distributor, maybe in this picture you can see the video distributor is board number 8, which is 1 2 3 4 5 6 7 8. This board here, it's a video distributor for the black burst. It receives 1 input and give us 6 output. This board, it has a name, a brand, a series number, serial number, everything, but it's generically defined as glue. It's something in the middle between source destination or one equipment another, which allow the equipment to work together. Without glue, the equipment cannot work together. In EQR1 and EQR2, we have 4 frames like this one with full of board which are used for glue system. In this case, as you can see, we have first 5 are distribution amplifier 2RG. Then we have a spare one, which is a free slot. Then we have a black burst analog distribution. Then we have analog audio distribution. And then we have 2 boards which are used for embedder and changeover that we will see in the next days. But each frame has 2 power supply. Frames can, in this configuration, the frame can work just with 1, but we have 2 for safety, because if one will fail, the frame does not power off, but still on because the power is supplied from the other one. And there are 4 frames exactly, well, with different configuration, of course, inside, but 4 frames like this one in EQR1 and EQR2. This frame can supply power to each board, but also they distribute the Ethernet connection, because through a proprietary software from Evertz, is it possible to check and verify through the Ethernet each single board inside the frame. They also distribute a reference, but in our case we don't use this function. This reference is used only for the main embedder and the changeover. distribution amplifier receive reference directly from the SPG. This is the configuration of the glue system for the 4-frame in EQR1, which is almost similar to the EQR2. So we have some distribution amplifier SDI video 12G. We have AS distribution amplifier. We have analog audio distribution amplifier. A lot of things inside. And we have a multiplexer. We have all these boards are not video generator or video destination, but they are the system on how to interconnect all the other device in the system. It's a glue, really glue. Okay, now we have a big chapter about the Evertz video router. Evertz video router concept, it's simple itself. Let's imagine to have a matrix realized like this one, where we have 4 lines called input and 4 lines called output. If I close the switch S1, the signal which comes from in 1 goes to the output 1. If I close the switch in S6, the signal which comes input 2 goes to the output 2. But if I close the switch S4 and still close S1, input 1 goes output 1, and at the same time the signal goes to the output 4. This is a video router. Of course, from the system, you cannot close S1 and S5 because you cannot mix 2 signals on output 1. Is it clear? Hello?
Yes.
Maurizio, it's like we use to find the program, to choose the program. It's like this, just an example.
It's used to send video from source to an output.
Yes, for example, when we choose the program.
The program
it's the same concept.
will use the mixer after Sony. The main role here.
No, okay. You mean the main program is generated by the video mixer, okay?
Okay.
Hello?
Okay.
But the output of the video mixer goes to the input of the router. And instead of being input 3, for 12G program is input 60. And the HD program goes to the input 62. And then when the programming comes in, you can send the program on every output of the router, just closing this switch.
Maurizio, in this case, we can send the signal from in 1 to more than 1 out, or it's impossible?
Yeah, you can send input 1 to all 4 output at the same time.
To all, you can do.
Yeah.
Okay, thank you.
Okay. This case, so The video router, there are two different types. They work exactly in the same way, but one type is a square video router, the other one is a rectangular one. So if you consider to have 4 input but just 3 output, is not square, it's a rectangular. Okay? If you have 3 input and 4 output, it's a rectangular, it's not square. When you have the same number of input and output, the video router is defined as square video router. In our case, we have 64 SDI in and 64 SDI out. That means our router is always square. Okay?
Okay.
The input, as we have already seen, we are working with 12G and HD signal. So the router itself doesn't care about if the signal is 12G or HD. Simply the router closes the switch and what appears here goes to the output. In other words, the router is auto-sensing. But of course, the difference is from source different and destination. I mean, if the source is HD output from the micro N UHD, but HD, not 12G, and the input, and at this output you connect a monitor which is only 12G, of course you can close this switch, but the signal HD goes through, arrives on the output 2, goes to the monitor in, but is not recognized, and the monitor still black. So you cannot damage anything, but simply you have black. If you connect different sources in terms in terms of standard. Is it clear?
Okay.
Okay. Perfect.
Wait a moment, please. There is a question.
Oh, sorry. We have one frame.
Sorry. 1 second, please. There is a
Yeah.
question. قرب ميكروفون يا أخو.
Can you hear me?
قرب لفمك.
Can you go back to the last slide?
Yeah.
In this case, how do we control the state of the switches?
You mean how you control this one?
Yeah, the matrix.
The switch.
Yeah.
There is a control panel. There are 2 types of control panel. It's CP1604 and CP6400. Maybe this afternoon Marco show you. Through this control panel you can control the router.
You can see it on slide number 23.
So it's done manually.
Yeah.
Through a control panel. شوف لا باج 23 في السلايد.
Okay, thank you.
We have in EQR 1 the router is contained, it is this board fundamentally. It's just one board, this one, and is inside into a frame which give to the board the power. We have 2 power supply here, and the Ethernet connection with the control panel to control the switching of the router. In the same frame, we have also the multi-viewer board. in EQR1. This is EQR1. EQR2 is a little bit different, but the principle is still the same. So this is the video router interconnection. So this board, if you see this board on the back of the frame, you have, this is the back of the frame, where we have micro BNC connection, output, the red one, and input, the blue one, and the SFP connection with the SFP with the micro BNC. In our case, the first 8 SFP here are not with the micro BNC, but are optical, because the router in EQR1 is connected directly with optical fiber to the router in EQR2. That means the two routers can exchange directly video signal at 12G. Is it clear?
Maurizio, so here we have virtual links.
What do you mean?
all
No, it's a physical link.
No, between router number 1 and the router number 2, EQR1,
It's
EQR2.
a physical link. There is one fiber from one source to destination, router to destination.
No,
Look,
about input
in this
and
way.
output.
Yes.
Yeah, look at
There is
this
fiber
picture.
output. كاين لي اس اف بي سورتي اونتري فيبر ديريكت ماشي بي ان سي كما
From EQR1 we have
fiber,
8 channel out,
في صورتي
33, 34, 35 and so on up to 40, which goes through fiber, one channel with 8 fiber to 8 channel fiber optic in to EQR2. Input 7024.
So all SFP are between the two routers.
Yeah.
Okay, thank you.
في بلاص ما توتيليزي اس اف بي بي ان سي ميكرو بي ان سي توتيليزي اس اف بي فيبر وتباتشي.
This afternoon you can see in the rear of the router. It's easy to see it. It's really easy. So these are the control panel which controls the router. Not directly, but the control panel are connected on the Evertz VLAN. Control panel send the command to the Manium server, and the Manium server software send the commands to the router. This is very simple one. When you press a button, you make you close a switch. This is more sophisticated because through the display you can see which switch are in place and which not. But they works at the same with the same principle. Okay, I have an external slide somewhere. It's this one. Okay. This is the diagram, schematics diagram of the video router, where we have if you remember before I told you well, here's the main output HD is in input 63 of the router. Then I can put input 63 on all the output of the router. 63 in 64, 63 in 63, 63 in 61, 63 in 59. I can set HD on 64 output of the router without problem. This red wire are optical fiber. We have 8 output from 33 to 40 to the router in bâtiment D. And we receive from bâtiment D 8 fiber to the input of the router. That means if you want to send a video and maybe with audio embedded on video, you can send directly from one router to another without anything in the middle. It's okay?
Yes.
Okay. Oh, this is the back of the router. If you look, yeah, this is the back of the frame, and we have in this position you can see the optical SFP here. But if you look at the rear of the rack, it's better because it's more clear. On the right, we have 3 multi-viewer board. Each multi-viewer has 16 input from 1 to 16, numbered in this way. This is multi-viewer 1, 2, and 3. And multi-viewer, the input 1 has the input and an output which goes to the monitor, but all the other, they have just the input, because multi-viewer receive many input from many sources and has just one output which give us the view of all the input, like this one. Multi-viewer schematics. Okay, this is the schematics of the multi-viewer, where we have 16 input and just one output. In this case, we have 2 output because every multi-viewer can control 2 different monitors. But what you see on the monitor is this one. Please, can you exchange the video? Okay, these are the monitor multi-viewer in EQR1, where we have router. This multi-viewer receive router out 13, router out 14, router out 15. Then if you send a picture on router out 15, you will see that picture in this position. This is multi-viewer output, as you can see. Is it clear?
Maurizio, please.
Yeah.
Could you give us a small topology about this this concept? What we have camera, we have router. What we have between them?
The multi-viewer and the router.
Okay. 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 Marco, can you switch to the schematics? Perfect. So let's consider multi-viewer 1. It's okay? Multi-viewer 1. We have 16 input. On each input, we have a video signal. And the output is a composition between all this signal. The composition is what you see on the Marco, please. This is the composition. In some input, you have directly connected camera 7, camera 8, camera 9, and camera 10. On other input, you have, for instance, the auxiliary 4 from the mixer. Then, if you change the input on the auxiliary 4, you will see change the picture inside here. I don't know if is the right answer to your question.
I want a topology. What we have? Maybe we have switches, multi-viewer, router, all the equipment between the camera, the source to the destination. Normally, the last level it's the router, video router, and the endpoint is the camera.
You mean you want to see the schematics?
Exactly. About equipment.
Oh yeah, but it's better if you see the schematics. Marco, sorry, Omar.
Yes.
You have printed out schematics.
They are in building A. Maybe
Are
you
in
can see
building
it
A, of
afternoon,
course,
yes.
yes.
On the
But
table.
maybe this afternoon you can check it.
Okay, thank you.
Because are are very, very large. It's
Some
full
source-
of content. It's not so easy to see on the monitor, for instance.
Some source
It's
go
better to
directly
have a
to
printed out
the
version.
router, Maurizio, like
Just
the
a
camera.
small topology, if you don't mind.
Small topology. Uh, we can do, yeah, why not? Yes, we can do that. Marco, please, can you switch to, yeah, just to have an idea, okay? So, let's consider just one camera. Oh, sorry. Okay, this is camera 1. Camera 1 is connected with 2 fiber to a device which is BPU. BPU is connected with SMPTE to the CCU. From the BPU we have 3 12G output.
And one HD. 3G.
The HD is from CCU, yes. This one goes to the
Mixer.
video mixer. This one goes to the video router, and that one goes to the multi-viewer.
Directly.
Okay, then the video mix output goes to a distribution amplifier. Distribution amplifier goes to the router, and then we have a PGM from the router, and also we have a PGM
From the video mixer.
directly from the mixer. Those two PGM, here we have a multi-viewer monitor connected. Okay, those two PGM goes into a changeover. Sorry, it's better if I use another type.
s'il y a une panne في البروغرام الاول يباسكولي الدوزيام بروغرام تشينج اوفر s'il y a un ديفو في البروغرام تاع الميكسر يسويتشي الروتور تبقى لك لا ميم
The
ايماج.
changeover output, the changeover itself continuously check if this one is okay or that one is okay. If one is broken, automatically brings the second output, and we have a PGM output always.
And we have two changeover, one with 12G and one for the 3G.
For the HD. Yes.
والكاتكا.
Sorry, just a second, please. So, we have installed here on the PGM, instead of using the automatic procedure, because sometimes make a fault itself, we have, you can see in AQR1,
manual button changeover.
Manual button, yes, on which pressing this one, you will change between this one to that one, and you still have a continuity output for 12G side. And you have also a controller for HD side, because we have one changeover for the 12G and one changeover for HD.
Le même principe. هذه ريكومونداسيون تاع لو ان تي في تاع لي بوطون مانيول باش لوبيراتور يكون عارف وين راه واش راه يوتيليزي اسكو راه يوتيليزي في المين ولا في الباك اب باسكو اوتوماتيكمون ما تقدرش تعرف الا السيستم راحت لك لا سورس برينسيبال وانت راك تخدم ماكش على بالك بلي راك في السكور كابابل في اللايف يروح لك كلش انت ماكش عارف سي بون وليد سي بون
Yes, it's very clear now. Thanks.
It's clear?
Yes, thanks.
Okay, perfect. So, Marco, please, can you change? Yeah, okay, thank you. Now, we have, as I told you, we have also video Sony switcher, which is a video mixer that we receive on the video mixer all the camera and all the other sources. We have 28 video input, 12 video output, 16 video output down converted, and 2 multi-viewer output. So, mixer itself has built-in multi-viewer for its input. What you see now in the slide is the front panel of the video switcher and the rear panel of the video switcher. There is a particularity about the input, because the switcher is equipped with this board, which is XKS S8112, which has 16 BNCs, because the board can work in HD, 3G, and 12G. But if you are working in 3G or HD, you can use all 16 input. But if you are working in 12G, we have just 1, 2, 3, and 4 input on each board. Because if you remember what I told you yesterday, 12G is a combination, is a multiplexing of 4-channel 3G. That means the power of the board use 4 BNC to build up just one channel 12G. That means each board can be used only on input 1, 5, 9, and 13. We have 7 boards like this one, and each board has 4 input. It means 28 input on the video switcher. Is it clear? Hello?
Yes, yes.
Okay. Same thing can be applied for the output board, because normally the output board can have 16 output HD or 3G, but in our case we use 12G output. That means a multiplexing of 4 channel goes in the output number 1, 5, 9, and 13. There are 3 boards plus 2. The first 3 are set in 12G mode. That means we have 12 output 3G mode. Then we have a 4th board which is used by the internal down converter, which is this one. And the down converter can be set in any way you want. Maybe you can set the program out here at 12G and the program out on output 5, 6, 7, 8 in HD. Can be set as you wish.
Programmable.
This is the down converter output. And the last board use only 2 BNCs because it is the multi-viewer output. If you look at the center of the video desk, there are 2 monitors, and those 2 monitors receive the signal directly from the multi-viewer from the video switcher. It's okay?
Okay.
Okay. One of the characteristics of the video switcher input is the capability of the switcher to accept 12G or HD. So, for instance, on input 1, board 1, I can tell the machine this is a 12G input, or I can tell the machine this is an HD input. Internally, there is an up converter which converts the HD to 12G. That means the video switcher can work with different format signal at the same time. Okay?
It's okay.
Perfect. This is video switcher control panel. So, this control panel that you see here in the picture, you can see that, okay? From a graphical point of view, is composed by these elements. All these elements are connected to a switch, which is MWS VLAN switch. MWS VLAN is a proprietary LAN Sony.
It's connected internally. كونيكتي على الانتيريورز ما تبقاش لي كابل هادو برا. Yes, Maurizio?
Yeah.
You
The
cannot see
connection
this
here
outside.
internally into the keyboard, we have just 4 Ethernet wire, 1, 2, 3, and 4, which arrives at the input of the keyboard.
Maurizio, for the switch, also the configuration is made by Sony.
Yes. You mean the video switcher, the video mixer?
No, the
keyboard.
MWS VLAN switch.
No. It's just a simple VLAN without any particular configuration.
Okay.
There is some parameter, maybe Marco remember well, if there are some parameter to be inserted, or maybe with Marco this afternoon you can see, but it's not a specific configuration. It's a very, maybe the dynamic host control protocol should be switched off, I think, something like that.
Okay, done. Thanks.
Okay, now we have schematics for the video switcher. Somewhere I should have, yes. This is the schematics of the video switcher. As you can see here at the input from 1. So let's take. This is 4 input on board 1. Okay, maybe it's not visible. Okay, you can see 4 input on board 1. Now we have 4 input on board 2, 4 input on board 3. Physically, each input is 01, 05, 09, 13. But from logical point of view, we have input 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay? Is it clear?
I think فهمتوها ليكيب هذه كيفاش تمشي. انت عندك في لي بوطون 1 2 3 4 مي من لاريير في الفيديو ميكسر راك ميتيليزي 1 5 9 13 باسكو سي 4 كا. اون 12 جي. اوكي.
Clear?
Yes.
Okay. Then, as you can see, we have camera from 1 to 18 at the first 18 input of the video mixer. Then we have a computer graphics, and then we have some connection on the patch panel, on which you can send into the video switcher as you wish through the patch cord. And last, we have some distribution amplifier, 12G video distribution amplifier, which has some output connected to the video switcher. Then, the first 18 input are fixed. Input 19 and 20 are dedicated to the Chironego, which is graphics computer. Input from 21 to 28 can be anything you want or you need to send in. Of course, if you send in a 12G signal, you have to tell to the machine, be careful, this input is 12G. If you send the input HD, you have to set into the software of the machine is HD. But it's very easy. I mean, maybe within some days when Sony people come there, show you how to do that. It's very easy.
It's
No
from the
problem.
computer, from the screen, touch screen.
Yes, from the touch panel on the screen of the switcher. Yes, absolutely yes. We have also 12 output, and if you remember, I told you we have one program output which is this one, and another program output which is this one. One goes to the main embedder and the changeover, and the other one goes to the router. You remember the drawing that I make before? We have one program which goes here and one program goes there. Really, this program is not direct. Oh, sorry. But goes through the router. So we have video mix output, distributor, router, and changeover. The other one is video mix directly to the changeover. And here we have this configuration. This one goes to the video distributor, then to the router, and output 12 goes directly to the changeover.
Embedder first.
It's clear?
Okay.
Omar, can I go on?
Yes.
Okay. Then we have some auxiliary output. In this case, are configured as auxiliary 8 HD output, HD, HD, HD. But on the other board, the auxiliary 9 is just 12G. And auxiliary 3 is just 12G. So if you remember, I told you before that the down converter board can be set as you wish, HD or 12G. This is a preset configuration installed, but it can be changed as you wish, no problem. And then we have multi-viewer monitor on output 5 and output 9 of the last board, which goes on the video desk. Any question?
It's okay. Oh,
That's okay, good. And now we have the back plane of the video switcher. This drawing is also on the printed out drawing, in which there is a cable number and position on the video switcher back plane. So, on the video switcher back plane, input 1, board 1, we have cable 20, 10, 11. In this position 5, we have cable 20, 10, 12. This is camera 1 and this is camera 2, and so on. As you can see, we have one cable every 4 positions. The other positions are empty. There are no cable connected. It's clear?
okay.
Hello?
Yes, yes.
Okay?
Yes.
Okay, perfect. So we are finished. Any question?
Est-ce qu'il y a des questions l'équipe? Parce que كملنا اليوم صباح البروجرام. Okay, Mauricio, thank you.
Okay, you're welcome. Of course, if in the afternoon you have a question, please ask to Omar, to Marco, to Ashmi, or otherwise you can also phone me, no problem.
Okay.
Okay.
Okay, thank you very much.
Thank you. Have a nice lunch.
You too.
Bye. Bye bye.